Good morning, everyone, and welcome. I'm Dr. S.K. Singh, and I'm pleased to be here with you today. Today's presentation is titled Types of Vials Used in HPLC Analysis. We'll be exploring the different kinds of vials that are essential for high-performance liquid chromatography. Over the course of this session, I'll walk you through the various types, their features, and how to select the right vial for your analysis. Let's get started. Welcome to the next part of our presentation. Let's start with the basics. What are HPLC vials? HPLC vials are specialized containers designed specifically for storing and delivering samples into high-performance liquid chromatography systems. They play a crucial role in ensuring the accuracy and reliability of our analytical results. Now, you might wonder why these vials are so important. Well, first, they help prevent contamination, which is vital for obtaining clean and trustworthy data. They also maintain the integrity of the sample from the moment it's placed inside until it's analyzed. This consistency is key to reproducible results, which is the foundation of good chromatography. Additionally, these vials are compatible with auto-samplers, allowing for automated, efficient sample handling. Minimizing sample loss and evaporation is another critical aspect. Proper vials help retain the sample's original composition, ensuring the results aren't compromised. Let's briefly look at their basic components. The main parts are the vial body, which holds the sample, the cap, which seals the vial tightly, the septa, which are the rubber or silicone membranes that allow needle access, and optionally an insert, which can help with small sample volumes or improve sample recovery. Here's an interesting fact to remember. A poor quality vial can lead to ghost peaks. These are misleading signals in your chromatogram, or cause sample adsorption, which skews your results and even lead to inaccurate quantification. So, investing in good quality vials is vital for reliable chromatography. Let's take a closer look at the major types of HPLC vials you'll encounter. When selecting a vial, you'll notice they are categorized by common features such as material, volume, and neck finish. For example, glass vials are widely used because they're inert and compatible with most samples. Plastic vials are a lighter, often more cost-effective option, though their chemical compatibility needs to be considered. Amber vials are excellent for light-sensitive samples, protecting them from degradation, while clear vials are suitable for samples that don't require protection from light. You'll also see different types based on how they seal, like crimp top, screw top, and snap top vials, each offering different levels of convenience and security. Insert vials are another category, often used for special applications or sample types. Choosing the right vial depends on several factors. The nature of your sample is crucial. Some samples are sensitive or reactive, so material choice matters. Solvent compatibility is also key, ensuring the vial material doesn't interfere with your analysis. If your samples are light-sensitive, amber vials are the way to go. The injection volume influences the size and design of the vial, and your analytical method might dictate specific requirements, such as compatibility with certain sample types or sealing mechanisms. In essence, selecting the appropriate vial is about matching these characteristics to your specific analytical needs, ensuring the integrity and accuracy of your results. Let's take a closer look at the example on this slide, which involves analyzing caffeine in energy drinks using a methanol water mobile phase. This illustrates how specific solvents can be employed effectively in chromatography to separate and identify compounds. Moving on to the advantages of glass as a material in laboratory settings. First, its minimal interaction with analytes is a key benefit. This means glass doesn't easily react or interfere with the substances we're analyzing, ensuring the integrity of our results. Second, glass tolerance to high temperatures makes it suitable for processes that require heating, like certain sample preparations. Third, glass is ideal for organic solvents because of its chemical inertness, meaning it won't react or degrade when exposed to these chemicals. However, there are some limitations to consider. For example, glass can adsorb trace levels of basic compounds, which could affect the accuracy of sensitive analyses. So, while glass is very useful, it's important to be aware of this potential issue. Now, let's discuss the main types of glass used in laboratory applications. Borosilicate glass is the most common. It's known for its durability and resistance to thermal shock. Type I hydrolytic glass is another important type, especially in applications requiring high purity and chemical stability. Finally, I want to highlight some key uses of glass in laboratories. It's widely used in pharmaceutical analysis, food testing, environmental analysis, and stability studies. Basically, in any application where chemical inertness and reliability are crucial. Regarding glass HPLC vials, they are essential components in many analytical workflows. Their features include being the most widely used in labs, largely because of their chemical inertness and high resistance to solvents. Plus, they offer excellent transparency, which is important for visual inspection and UV detection during analysis. Overall, glass's combination of chemical stability, durability, and transparency makes it indispensable in many analytical and preparative processes in the lab. Now, let's take a look at plastic HPLC vials, which are commonly used for analyzing protein or peptide samples in bioanalytical HPLC. These vials are designed to hold samples securely and are quite popular in many laboratories. One of the key advantages of using plastic vials is that they are safer to handle, reducing the risk of injury or breakage during sample preparation and analysis. They are also less likely to break compared to glass, which makes them especially suitable for high-throughput labs where efficiency and safety are paramount. However, it's important to note their limitations as well. Plastic vials are not compatible with strong organic solvents such as acetone or chloroform, because these solvents can degrade the plastic or cause contamination. In terms of features, plastic vials are lightweight and break-resistant, making them convenient for everyday use. They are also economical, which is a significant benefit when working with large numbers of samples. As for their common uses, these vials are ideal for biological samples, routine quality control analysis, and aqueous solutions. They are typically made from materials like polypropylene or polyethylene, both of which are durable and cost-effective. In summary, plastic HPLC vials are a practical choice for many bioanalytical applications, especially when safety, durability, and cost are considerations. But always keep in mind their solvent limitations to ensure reliable results. Let's talk about the different types of HPLC vials, specifically clear and amber vials, and when to use each one. Clear vials are typically used for general-purpose analysis and are ideal for non-light-sensitive compounds. For example, if you're analyzing sugars in beverages, clear vials work perfectly since these compounds are stable without protection from light. On the other hand, amber vials are designed for light-sensitive samples. They help protect UV-sensitive compounds like vitamin A or riboflavin, which can degrade if exposed to light during analysis. The key difference here is that amber glass blocks UV light, providing a protective barrier that helps maintain the stability of these sensitive analytes. It's really important to choose the right vial color because selecting the wrong one can compromise analyte stability and, ultimately, affect the accuracy of your results. So, always consider whether your sample is light-sensitive or not, and select the appropriate vial accordingly. This small but crucial choice ensures the integrity of your analysis and reliable data. Now, let's talk about screw-top HPLC vials. These vials feature a threaded cap design, which makes them really easy to open and close securely. This design provides an excellent sealing capability, helping to prevent sample contamination or evaporation. They're commonly used in routine HPLC analysis, especially when you need quick access to samples. They also work well in LC-MS applications, where maintaining sample integrity is crucial. Laboratories that handle frequent sample access often prefer these vials for their convenience and reliability. For example, in pharmaceutical labs, they're often used for tablet formulation testing, ensuring consistent and accurate results. One of the main advantages of these screw-top vials is that they're user-friendly. They make sample handling straightforward. Plus, they can be reused in some cases, which is both economical and environmentally friendly. And because of their tight seal, there's a lower risk of evaporation, which is important for maintaining sample stability. However, it's important to remember that improper tightening can lead to leakage. So ensuring the cap is securely tightened is key to avoiding sample loss or contamination. Overall, these vials are a practical choice in many analytical settings, provided you pay attention to proper sealing. Let's take a closer look at crimp-top HPLC vials. These vials feature an aluminum seal that is secured using a crimping tool. This design ensures an airtight seal, which is crucial for protecting your samples from contamination and evaporation. The primary goal here is maximum sample protection, especially when dealing with sensitive compounds. These vials are particularly useful for analyzing volatile compounds, or when you need to store samples for long periods without compromising their integrity. They're also ideal when working with sensitive analytical methods where even minor contamination or sample loss can affect your results. A good example of their application is in residual solvent analysis in pharmaceuticals, where maintaining sample integrity is essential for accurate testing. Now let's discuss the advantages. Crimp-top vials offer excellent sealing integrity, which means your samples stay sealed and uncontaminated. They also minimize evaporation, helping preserve the concentration of volatile components. Plus, their design reduces the risk of contamination, ensuring cleaner, more reliable results. Of course, there is a limitation to consider. These vials require specific crimping and decrimping tools, so you need to have the right equipment on hand to use them effectively. Overall, these vials are a valuable tool in the lab for securing sensitive samples, but they do come with some operational considerations. Now let's take a closer look at the snap-top HPLC vials. These vials feature a push-fit cap system, which makes sample preparation quick and straightforward. This design allows for convenient handling, saving time and effort during your workflow. They're particularly useful for fast, routine testing, especially in environments like academic laboratories where efficiency is key. They're also ideal for high sample throughput analysis, enabling you to process a large number of samples quickly. A common example of their application is routine water quality monitoring, where speed and ease of use are critical. When it comes to advantages, these vials offer fast operation because you don't need any special tools to open or close them. Plus, they are quite cost-effective, making them a practical choice for many labs. However, it's important to note a limitation. The seal isn't as secure as that of crimp-top vials. So, if your application requires the utmost sealing security, you might need to consider other options. Overall, the snap-top HPLC vials are a versatile, efficient choice for many routine analytical tasks, balancing convenience and cost with a few considerations regarding sealing security. Now let's take a closer look at inserts. So, what exactly are inserts? They are small inner tubes that you place inside standard vials to hold low sample volumes. This design helps us manage very small amounts of samples more effectively. In terms of uses, inserts are especially valuable when working with precious samples or when performing low-volume injections. They're also widely used in biological and forensic analyses, where sample conservation is critical. For example, in impurity profiling, we often only have 100 to 200 microliters of sample available. Using inserts allows us to analyze these tiny amounts without wasting valuable material. One of the key advantages of using inserts is that they reduce dead volume, which means less sample is left behind in the vial and more is available for analysis. This also improves sample recovery, making sure we get the most out of every drop. Plus, since samples can be expensive, using inserts helps us save these valuable resources. There are different types of inserts to choose from, depending on your specific needs. Some common types include flat-bottom inserts, conical inserts, and polymer feed inserts. Each has its own unique design to optimize sample handling and compatibility with various analytical methods. Overall, inserts are a simple but powerful tool to enhance precision, conserve samples, and improve the reliability of our results in low-volume applications. Let's take a closer look at this example. PTFE and silicone septa are commonly used for acetonitrile-based mobile phases because they offer excellent chemical resistance and sealing properties. Now, an important point to remember is that the vial cap system is just as critical as the vial itself. A proper seal ensures the integrity of your sample throughout the analysis. Moving on to the uses of septa, selecting the right septa material is essential to prevent issues like sample evaporation, which can lead to concentration changes or loss of analytes. It also helps prevent contamination from external sources, which could compromise your results. Additionally, a good septa minimizes coring issues, where pieces of the septa get into your sample, and carryover, which can cause cross-contamination between injections. Now, let's talk about the importance of caps and septa. The materials used matter because they need to be compatible with your solvents and analytes. For example, PTFE and silicone are popular because they are inert and resistant to many chemicals. Other options include rubber, butyl, and polyethylene, each with their own advantages depending on your specific application. When selecting septa materials, consider the key criteria. Compatibility with your solvent is critical. Some materials can swell or degrade if they're not compatible. Needle penetration resistance is also important, especially if you're performing multiple injections. You want a septa that can withstand repeated punctures without losing its sealing ability. And of course, chemical inertness is vital so that the septa doesn't react with your sample or interfere with your analysis. In summary, choosing the right septa and caps is a crucial step in maintaining sample integrity and ensuring accurate, reliable results in your analysis. When selecting vials, it's crucial to consider several factors to ensure optimal sample integrity. First, look at the sample chemistry. Certain compounds may interact differently with vial materials. Next, consider the solvent type, as some solvents can be more reactive or cause degradation depending on the vial. Detection sensitivity is also key. Choosing the right vial can improve measurement accuracy. And don't forget storage duration. Long-term storage might require specialized vials to prevent issues over time. Now, many problems stem from using the wrong vial material. For example, basic compounds can interact with glass surfaces, leading to low recovery of your analytes. This can cause a series of issues like ghost peaks, which are false signals, or sample adsorption, where analytes stick to the vial surface. You might also see peak tailing, evaporation of the sample, contamination, or even needle blockages during analysis. So, selecting the correct vial isn't just a matter of convenience. It's fundamental to the quality and reliability of your results. By understanding these causes and problems, we can better troubleshoot and prevent errors, ensuring our data remains accurate and reproducible. When selecting the right HPLC vial, there are several important considerations to keep in mind. First, chemical compatibility is crucial, making sure the vial material doesn't react with your sample. For example, light-sensitive samples should be stored in amber glass vials to protect them from degradation. Sample stability is another key factor. Choosing a vial that maintains your sample's integrity over time is essential. Injection volume also matters. If you're working with very low sample volumes, using an insert vial can help improve accuracy and reduce waste. Auto-sampler compatibility is important too, so ensure your vial suits your auto-sampler's requirements for secure sealing and proper fit. Cost-effectiveness shouldn't be overlooked either. Finding a balance between quality and budget is always wise. To help guide your choice, I've prepared a handy table. For light-sensitive samples, amber glass vials are recommended. For organic solvents, borosilicate glass works best because of its chemical resistance. Biological samples are best stored in polypropylene vials, which are inert and safe. If you're dealing with low sample volumes, using an insert vial helps. For volatile compounds, crimp-top vials are ideal to prevent evaporation. And for routine analysis, screw-top vials provide a reliable, easy-to-use option. Ultimately, choosing the right vial is about matching these key requirements to your specific needs, ensuring accurate, reliable results in your analysis. Industry demand is really driving the evolution of modern analytical labs. Today, labs require higher sensitivity to detect even the smallest quantities of analytes. At the same time, there's a strong need for lower contamination levels to ensure accuracy and reliability of results. Better reproducibility is also crucial, so we can trust that our measurements are consistent over time. And of course, faster workflows are essential to keep up with the increasing volume and complexity of samples. Looking ahead, the future trends in HPLC vials are quite exciting. We're seeing emerging developments like low adsorption vials, which help minimize sample loss and improve detection limits. Certified clean vials are becoming standard to ensure the highest purity, and LCMS-certified vials are tailored for compatibility with mass spectrometry applications. Smart barcode vials are also gaining traction, allowing for better sample tracking and data management. Plus, eco-friendly recyclable vials are increasingly important as labs aim to reduce their environmental footprint. These innovations aren't just for routine analysis. They're critical for advanced applications such as proteomics, metabolomics, ultratrace analysis, and biopharmaceutical testing. Each of these fields demands the highest level of precision, sensitivity, and reliability, making these new vial technologies essential tools in modern laboratories. Overall, staying ahead with these trends not only enhances performance, but also aligns with the evolving needs of scientific research and quality assurance. Let's wrap up with the key takeaway here: the importance of HPLC vial selection. As we've discussed, the choice of vial can directly impact the accuracy of your analysis. Different applications require different types of vials, so understanding what's best for your specific needs is crucial. Factors like the material of the vial, the type of cap, and whether the vial is compatible with your samples all play a vital role. Using the proper vial isn't just about convenience. It actually improves the reproducibility of your results and enhances instrument performance. Remember, in HPLC analysis, even the smallest container can make the biggest difference in your data quality. So, paying attention to vial selection is a simple yet powerful step toward more reliable and accurate analytical outcomes. For further support, please don't hesitate to reach out. If you have any questions or need additional information, I'm here to help. Thank you so much for your attention and engagement throughout this presentation. Remember, we're all in this together, and your success matters. Feel free to contact us anytime. We're just a message or call away. Thanks again, and have a great day.